Hello, this is Rob from FLO-2D, and today I'm going to show you how to use ERA5-Land dataset into your FLO-2D real-time rainfall simulations. So if you Google ERA5-Land, you're going to get into this website, cds.climate.copernicus.eu, and this is the website where you can download the ERA5-Land datasets. So for those who don't know, ERA5-Land is a reanalysis dataset. Basically, it combines the model data with observations from across the world into a globally complete and consistent dataset using the laws of physics. Basically, it produces data that goes several decades back in time, providing an accurate description of the climate of the past. So basically, it has hourly data from 1950 up to 3 months ago, if I'm not wrong. Okay, so you need to sign in for this kind of data. So as you can see here, I am already logged in. So that's why I can go to download here. And as you can see, we can download temperature, snow, soil, water, radiation, and heat, many types of data you can obtain through this ERA5-Land dataset. What I'm going to do here, I'm going to download total precipitation. So basically this is hourly total precipitation. And I'm going to select 2014, 2024, sorry, because last year we had a huge flooding event here where I live, and I'm going to use this as an example to you all. Okay, so basically I'm going to get the data from April, from let's say 25, 26, 27, 28, 29, and 30. So for all times, here, geographical area, you can download that for the whole globe, but that's going to take a lot of time to download and process that data. So I'm going to use a sub-region extraction. To do that, here I have like my QGIS FLO-2D project. Basically, I'm going to get the north, west, east, and south. So this should be in the WGS 84. So basically to do that, to just right click around here, copy coordinates. So this is minus 27 north. So let's go for, yeah, minus 27, I think is enough. Minus 27 north. South here, I'm going to get minus 31. Minus 31. West, I'm going to pick here minus 29. Oops. Minus 55 east. And east here, I'm going to get minus 49. Minus 49. So we need to use the netcdf4 as data formats. And it would be nice to have this as a zip file. Select the zip, and then you click on submit form. It's going to take you to this web page here, where you can see the that is queued here. Those are the data sets that I downloaded before. So we need to wait a few seconds here. It doesn't take a long time. You can click on check status here, and it's pretty fast. Let's wait a little bit. I'm probably going to pause the video here. Okay, so it took like 33 seconds to process this data. You just click on download, and then it's going to download into your computer here. It comes as only one file here. Let me just resize this. So this is on the zip file, so I'm just going to extract that to a new folder called netcdf2 here, because this is just an example. I'm going to save this. So this is the only file that you need, okay? On your QGIS, you just have to simulate rainfall, real-time rainfall, raincell.dat. So now you have the option to select next red, which is what we always did using the .asc files. You can also select the .t files and the ERA5-Land. So just click here to import the data. Let me just move to the folder. So this is the one that I just downloaded here. NetCDF2, yeah, this is correct. Just click on open and it's going to process the data. So let's wait a little bit for it to process the data. Okay, it's importing the ERA5 rainfall right now. It's kind of fast to import the data. I'm going to pause the video and wait for it to finish. Once it is done, you're going to see this message on the bar here. For those who are more advanced users, you can check the advanced layers. Go to the rain tables and you are going to see that we imported all 5 days here with the timestamp correctly here. Not going to open the rain real-time rainfall data here because it's going to take a while to load that. Okay, so on FLO-2D, you are good to go. So you just quick run your project here and you are going to see the rain cell.dat, which I'm going to show you in a second. So I already have a run here, but basically your rain cell, it's going to look something like this. You see it's kind of a heavy file. You can use the HDF5 as well to where you don't have like such a huge file in your projects. But this is the rain cell.dat and it's going to run and I'm going to show you the results in a second here. But before that, I want to show you what the netcdf file looks like. So this is the one that we just downloaded. So QGIS understands this kind of data, but it understands in a very weird way. So you can just drag and drop it. So you're going to see this message. This is a mesh data set. Both are the same. Both are going to show you the same data, but this one is a mesh and this is a raster. And I think this is better to show you all as a raster here because it makes more sense for me. So if you add this, each band, it's going to be a time. So it starts at the selected time. So basically, if I click here and I need to select this as WGS84, even though I'm in this projection here, this data is in WGS84. So you need to select this one so you can see the data. So basically, this is how it looks like. So this is the first time interval that I selected. So you can use this guy here to see the value. So this is, you need to multiply that by 1,000 to get that in millimeters. So this is only going to work directly this way if you are using meters here. So you need to multiply that by 1,000, but then you can see that it changes. So if you want to get the next hour, you just need to select the next band here. So you see it's going to change a little. So this is how you can see the netcdf data. So in this project here, I just added some elevation, as you can see here. Let me just zoom to the layer, and I added some mannings here. And then I ran this project for, I think I ran it for 15 days or something. So what I'm going to do next, I'm going to select this, the run that I did previously. I'm going to select this file here, click on add. It's going to take like some seconds, I would say almost a minute to load this because it is a huge time-dependent run here. So let's check out the size of the out file. So it's around 6 gigabytes. So it takes some time to load the mesh here. So let's wait until it loads. Okay, it's done here. So I can close. So I need to change some stuff here so we can see the water flowing. So the first thing that we need to do, we need to select the flow depth here. Click on apply. Then we need to select this as the minimum. I would say 0.15. I prefer to not use a resample method. So we are going to see the grids, and I like to clip out of the range values here. And as you can see, this has the temporal marker here. So you can click here. Let's close the FLO-2D grid info. Mark this to set full range, and then we can see the, let me just uncheck the grid here. It's going to be better if I do that. So we are going to see that for this data set, for this period that I selected last year, it started raining on those regions here first. And as we go, we have a strong rainfall here. And as you can see, we barely had any rainfall on this portion here. And as we go, we can see that the rivers are getting full of water. And then you can see that the rain comes a little bit from this portion here. So you see that also in this moment here, we have more rainfall coming here. And then we have like a very huge rain in the whole watershed here. And this is how it looked like using the real-time rainfall from the ERA5-Land. Okay, we can also change this to the neighbor average if you like. I don't like that. It looks better, but for me, I think the best is to show the grid here. This is just a resample method. The correct one should be no resampling. Okay, thanks for watching. If you have any questions, please let me know. Okay, bye.